Hello everyone, this is Dr. Indradeep Kumar, Assistant Professor, IARE, Hyderabad. So in this video, we will see Clapeyron's 3-moment equation for uniform load over entire span. We had seen already the derivation, and in that we also had seen that how to, for that one table was there in that video, that depending upon how the loads are there, based on that we can find the 3-moment equation. So earlier that we had seen in the previous video, that was a generalized one, but now the specific condition is what? Uniform load over entire span. So this we will see in this video. Okay, so just see, now this is the loading, that any arbitrary loading is there that we don't know right now. First we are seeing for this arbitrary loading, and then we will replace this loading to the entire span, means from here to here, like this, uniformly loading, right? So first we are deriving for the general case, and then we will replace this general case to the whatever the condition is given. So here condition is given for uniformly distributed load, right? So for that we are, so let's see, first here we are dividing into two parts, just considering from here, here and here. So from here 1 to 2 and 2 to 3, this part load is there. So just see, loads on simply supported beam. In our case, the whole load will be from here to here, that we will put later. First we will see the generalized way. So now how the load is there? So here this is the load on simply supported beams, just divided into two parts. From 1 to 2 the length is L1, from 2 to 3 the length is L2. So now just we are dividing and we are seeing the load, how that is there. So just see, here you can see the load that replacement, that this one reaction is acting vertically upward. So V1 and V2 at this point, V1 and V2, and here is V3. So this is V2, V1, right? And at point 1, moment is acting clockwise M1, and at V2 it's acting anti-clockwise M2. Similarly, this side at V2 the moment M2 will act clockwise, and at 3 that is moment will act anti-clockwise M3, right? So this is the load distribution. Now what we have to do, the moment diagram. Okay, so moment diagram of load on simply supported span. So just see here, so this will be the area over this one. So from here to here that will be for A1, okay, and from here to here that is for B1. This A1 and B1, that only is required to substitute the value of that. Overall it's a simply supported, means or it's a UDL is there, UVL is there, or point load is there. Now the moment diagram of loading by end moment. So what moments are there? That end moments, this is moments because of what? Load, right? And this is moment because of this, that moment diagram because of these moments, right? So you see in this figures for this part, and this is for A2 and B2. Now in this part, this side moment is acting, right? So here, let's see, you can see here. So this side, that greater moment will act. That's why M1 side, this one is greater, and from where it will act up to M1 to M2, so up to this 2. But now this moment will divide into both the cases. Here also M2, that is anti-clockwise, and here M2, that is clockwise. So their effect will be lesser. So now here M2 is there, which will act up to 1, right? So that's why M2 to 1. Similarly in this case, that M2 will be small, so small, just you can see here, and M3 in moment is there, so here M3 is the larger one. Okay, so this is the load and moment diagrams. Now this figure is important. Once you understand this figure, after that the question becomes very easy. Okay, so now let's see what is there. So after the bending, you can see this bending here. Okay, this part, just here, from here to here it is given as H1, right? And here that is H2. So from this curve you can see here in this figure, right? So for this only, just exaggerated is here. So now just see, this is the point 1, this is point 2, point 3, that is there. Now here, so this side, this is the moment diagram, this will be smaller, and this is our baseline. Remember, this is our baseline, right? So this is above the baseline, and this side it's below the baseline. right? From here to here distance is L1 and L2, that is given. Now here this height is given in the figure. You can see, just see here, that H1 from here to here, and this side H2, right? So this height is H1, right? And this height is T1 to 2. That how much deflection is there in T1 by 2 is not there. It is 1 to 2. So from 1 to 2, how much deflection is there? That is here. So from, if this total is H1 and this is what? T1 to 2. Then what we will get? This value. This value will be what? H1 minus T1 to 2. Similarly, this side, this was given as H3. Okay. And this total is the deflection from 3 to 2 because of 3 to 2. So T3 to 2. Then what will be this one? Right. This will be 3 T3 to 2 minus H3. So this total minus this one. Why this we required? Now here we will apply the similar triangle property. So in this triangle, right, one triangle is here and another one is here, right? So these two similar triangle, we can say this angle is equals to this angle, this side is common and this side also is common. Hence these two triangles are similar triangle. Now just apply the similar triangle formula. So this base is given as L1. So this height divided by this one equals to this height divided by this one. So this height is how, this is how much? H1 minus T1 by 2 divided by this is L1. For this case, this is how much? L2 and this is. So first this we will take this. This is T3 to 2 minus H3 by L2. Okay. So now this figure over. Now just separated this one. H1 by L1 minus T1 to 2 by L1 plus T3 to 2 by L2 minus S3 by L2. Here, this step, just different, that separated the terms. Now collect what? H1 one side, T one side. So now this will come to this side and this will come to this side. So after that, what will get? T1 to 2 by L1 equals to 2, T3 to 2 by this one. T1 to 2 by L1 plus T3 to 2 by L2, which is equals to H1 by L1 plus S3 by L2. So this is the equation. Now here we have to find this T1 to 2, T2 to 3 and all, and then we can substitute back here. Let's see. Values of T1 to 2 and T3 to 2 that we required. Right. So now let's find first T1 to 2. So that you know the moment that deflection, that M by I equals to that mx. So this one by EI, that bending moment equation. So from there 1 by E1 I1 into area from 1 to 2 into x1 bar. X1 bar is what? Where the center of gravity of that figure is lying. Right. So now taking 1 by 1. So first total area. Right. So A1 for the first part. Right. This black. Right. A1 into whatever the area is there, that a small area. Okay. Plus this moment, from the moment half, just here. Okay. This figure, or you can say from here, half area of this one, half base into height. Right. So base is what? L1. Height already we found. Right. So yeah, half M1 L1, because M1 is the height. Right. So see here, M1, here M2. M2, M3. Half M1, and where it will lies from, if you will take this side, then 1/3. Then from this side, it will be 2/3 of that one. Right. So half M1 L1, and this is the X1 bar value. Similarly, for the what? This triangle, this a smaller one. Okay. So that will be half M2, distance is same L1, into, from this side we are taking 1 by 3, means opposite side it will be 2 by 3 L1. So this is now just simplifying. After simplifying, T1 to 2 we will get 1 by 6, is just 6 multiply, so that we will get the same thing for other equation also, that other equation also. So T1 to 2 will be equals to 1 by 6 E1 I1 into 6 A1, capital A1, small E1, that is center of gravity where it's lying, plus M1 L1 square plus 2 M2 L1 square. So this is T1 to 2. Similar way, now T3 to 2. So 1 by E2 I2, area of 2 to 3 into X3 bar, where the CG of that will be there. So 1 by E2 I2, similar way, A1, capital A1 now. So this time A2 B2 bar plus half M2 L2. Same from here. Half M2 L2. And this side if we are taking at 1/3, then for this one it will be 2/3, right? So 2 by 3 L. Okay. So now here. So for this side we are taking 2/3 of L by 2. So 1 by 2 M2 L2 into 2 by 3 L2 plus half M3 L2 into 1 by 3 L2. So after simplifying, what we will get? T322 as 1 by 6 E2 I2 into 6 A2 B2 bar plus 2 M2 L2 square plus M3 L2 square. So now we have T122 and T322. Next step, substitute in the previous equation. So just see, substituting T122 and T322 to equation 1. So just simply, just see what is the equation. Here, this one. This T122 by L1 plus T322 by L2. This remains same. Okay. So after substituting here, right, this divided by L1 is there. So now just see here, L1 square was there. So with this term, L1 was not there. Here, with this term, L1 is not there. Or simply, you can say divide here by L1, right? Just see here, that is there. By L1. So T122 by L1, right? And so this L1 for this will get cancelled. This also will get cancelled. And here it will get divided. Similarly, here you have to divide by L2. So with this term, L2 will be added. Here this will get divided by L2 and here also one L2 will get removed. So after simplifying that, this will be what? Here. So 1 by 6 E1 I1 into 6 A1, small a1, that A1 bar by L1 plus M1 L1, that 2 taken common, plus 2 after taking LCM, plus 2 M2 L1 plus, this is for the T2 to 3, sorry 3 to 2, 1 by 6 E2 I2 into 6 A2 B2 bar by L2 plus 2 M2 L2 plus M3 L2. That is equals to the right side, what was there? That is H1 by L1 plus H3 by L2, right? So now, just for simplifying even further, multiply both sides by 6. So after multiplying, what you will get? 1 by E I, because this 6 will get cancelled after multiplying, right? So here simply 1 by E1 I1 into 6, this whole thing will be same up to this step. Only with this step 6 will get multiplied. So here 1 by E1 I1 into 6 A1 small a1 bar by L1 plus M1 L1 plus 2 M2 L1 plus 1 by E2 I2 6 E2 small B2 bar by L2 plus 2 M2 L2 plus M3 L2 is equals to 6 into H1 by L1 plus H3 by L2. Right? Now this is there. Now just what? Divide 1 by EI. Or just you can say in another word, multiply by EI. Right. So whatever term is there. So now just see here. This one. Just here. Sorry, distribute one. So just multiply this term to all the terms. So this into this one. Similarly, this into this one. This into this one. So just see here. 6 A1 small a1 bar by E1 I1 L1 plus M1 L1 by E1 I1 plus 2 M2 L1 by E1 I1 plus 1 by now multiplying this side. So that's why 1 by EI is given, not 1 by E1 I1, because here this also you have to distribute or multiply. So now 6 E2 B2 by L2 into E2 I2 plus 2 M2 L2 by E2 I2 plus M3 L2 by E2 I2, which is equals to what? 6 into H1 by L1 plus H3 by L2. Okay. So now from here, combine similar terms and rearrange. Just whatever is there, like L1, L2 is there, just take that term. H already one side is there. So now after combining, so see M1 by L1, M1 L1 by E1 I1 plus 2 after taking common from M2 L1 by E1 I1 plus L2 by E2 I2 plus M3 into L2 by E2 I2 plus 6 A1 small a1 bar by E1 L1 I1 plus 6 E2 B2 by E2 I2 L2. Okay. That is equals to 6 into H1 by L1 plus H3 by L2. Now, so this is our formula after rearranging. Now, with conditions. Now, let's see how once we will change the condition, the formula will also change. So if E is constant in this equation, means Young's modulus of elasticity of that material is constant, right? Then what happened? So you can simply replace E1 to E, and then you can take E common from all the terms also, or simply. So just see here, M1 L1 by I1 after taking 1 by E common. Okay, so 1 by E common here. So M1 L1 by I1 plus 2 M2 into L1 by I1 plus L2 by I2 plus M3 L2 by I2 plus 6 A1 small a1 bar by I1 L1 plus 6 A2 B2 bar by I2 L2 equals to what we have 6 into this one, but this 1 by E. So this E got multiplied this side. So this becomes, now that's why this is not there, 6E into H1 by L1 plus H3 by L2. So this is when E is constant. Right. Now if I is also constant, like moment of inertia also constant, then what happens? I1 becomes I. Same way we can take 1 by I common. So after taking 1 by I common, M1 plus M1 into L1 plus 2M2 into L1 plus L2 plus M3 L2 plus, now with this because of this one, just see here. Right. So 6 A1 small that A1 bar by L1 plus 6 A2 B2 bar by L2 equals to what? After taking 1 by E, sorry 1 by I common, so this I get multiplied here. So now 6E becomes 6EI, and here I would be there into H1 by L1 plus H3 by L2. Right. So this is case when E and I is what? Constant. So in this case E and I is constant. So now let's see, this is the general formula. If E is constant, then same formula reduced to this one, and if E and I both are constant, then formula becomes this one. Okay, now here we have to replace this value. Okay, just substitute a value according to the table and we will get the final answer. So just see here. Now, so this is next. For the application of three moment equation, two continuous beam point 1, 2 and 3 are usually unsettling support. Unsettling support means what? That it should not be. Thus H1 and H3 are 0. Hence H1 and H3 are, let's see here in figure itself we can say unsettling support means that gap should not be there. That should be the equal of total whatever the moment is there. Hence H1 and H3 is 0 means right side term totally becomes 0. From here H1 and H3 is 0. So this total term becomes 0. So this term equal to 0. That is here. So M1 L1 plus 2 M2 into L1 plus L2 plus M3 L2 plus 6 A1 into A1 bar by L1 plus 6 A2 B2 bar by L2, that is equals to 0. Okay. Now, then for uniform load over entire span. So now for entire span we have to find. So this W naught is the weight for that uniformly loaded. That weight is given for the entire span of length L. So now from that one, 6A1 small a1 bar by L1 plus 6A2 small b2 bar by L2. This value we have to substitute. Okay, or just here, substituting the value of 6AA by L and 6AB by L. So 6AA by L from that table, it's a W naught LQ by 4, and for 6AB by L, it's a W naught LQ by 4, right? In equation 1, just substitute in the previous equation. So now, or in this also you can say here, or directly we can substitute here also if E is constant. So first again we are starting from this one, right? We are replacing this. Okay, if because E and I is not constant that time. If E and I, then again we will modify like this one. So substituting there. So now after that M1 L1 by E1 L1 plus 2 M2 into L1 by E1 I1 plus L2 by E2 I2 plus M3 L2 by E2 I2 plus here. This is for 6A1 A1 E1 bar by L1, that is W naught LQ by 4, right, into E1 I1 plus this is for 6A2 B2 by L2. So W naught LQ by 4 E2 I2 is equals to 6 into H1 by L1 plus H3 by L2. So this is from this equation. Okay. Now, if E is constant, then here this will change, right? Remaining everything will same. Only these two terms will change in all this one. If E and I are constant, then this becomes what? M1 L1 plus 2 M2 into L1. This is L1 subscripted plus L2 plus M3 L2 plus W naught LQ by 4. So this is only is changed, and this is W naught LQ by 4 equals to 6 into H1 by L1 plus S3 by L2. Right? Now for unsettling condition, means what? H1 and S3 should be equals to 0. So when H1 and S3 is 0, that time what happened? This side, it will be 0. Hence, M1, L1, same, just this equals to 0. Plus 2 M2, L1 plus L2. Again, this should be here in subscript. Plus M3 L2 plus W naught LQ by 4 plus W naught LQ by 4 is equals to 0. So this is the final Clapeyron's three-moment equation for uniformly distributed load. Means what we have to do, we have to just change these values depending upon which type of load is there here, right? So in this equation, or you can say if even I1 is not constant, then here just need to change what? This values. So till everything remains same, only the thing these two values will change, and that for already I given you, and in previous video also we discussed about the value of these things according to the load, how the load is acting. For point load it will be different, for uniformly distributed load it will be different, like point load acting at the midpoint, then it will be different, or if you are acting at some particular distance, right, then it will be different. So just how the load is acting, that value from that chart simply you have to put. That's all. Remaining everything will be same. So instead of doing from the beginning itself, just do the normal derivation, because that will help to derive anything. If suppose in exam it's a coming, how to derive? Derive for the point load. Then instead of considering that point load itself, just derive in the normal way, and later just change these two values. Okay, and that's all. Just simplify, you will get the final answer. Okay, so just see once again quickly. Now the question is, for uniform load we have to find for the uniformly distributed load Clapeyron's three-moment equation we have to find. So this figure, just a common figure, in that what we did, we divided into two parts, like 1 to 2, 2 to 3. Now for 1 to 2, this is the load distribution, 2 to 3, this is the load distribution with the span length. So L1 for 1 to 2 and L2 for this one. Now for this one is because of moment, because of the load acting. So this will be the moment for part 1, and this is for part 2. This is the end because moment, because of the end moment that is acting here, like M1, M2, M2 and M3. So this is the diagram of end moment. Okay. Now, so this only is the important thing that you have to find. So from here, what we consider there, this is the baseline, right? From here, this height is given as H1, and from here, this is H3. Okay, so this is our baseline, is this total we required. So for this, what we have to find? We have to find this distance. For finding this distance, what? This is total is H1 and this is T1 to 2. So means definitely this is H1 minus T1 to 2. Now this is H3 and this is T3 to 2. That is coming downwards. That's why this time this becomes greater or larger. So T3 to 2. So now this will be what? T3 to 2 minus H3. Now just apply the similar triangle condition in this triangle and in this triangle. Then you will get H1 by T1 to 2 minus L1 equals to T3 to 2 minus S3 by L2. Now just separate the term, right? After separating term, now what is required? To find T1 to 2 and T2 to 3. So just by bending moment equation, T1 to 2 equals to 1 by E1 I1 into area of 1 to 2 into x bar, where the CG lies. So now just putting the values, after putting the value, finally after simplifying you will get this one. So now this is the T1 to 2 value. Now T3 to 2 in same way, 1 by E2 I2 into area of 2 to 3 into x3 bar. The same thing will be there, just where you are taking the moment. One side it will be from left to right, it will be at 1/3, then second it will be 2/3. So whenever the bigger side of the moment is there, that side it's at 1/3, and the smaller side it's a 2/3 distance. So this Yes, here. So now T2, 3 to 2 also we have. Just substitute in the previous equation. After substituting, we got this one. Now, these are just simplification. What? Just multiply by 6. Then multiply by EI inside. And here with these two terms, E2, I2. After multiplying overall, we got this one. Next, just combine similar terms. Just rearrange. Whatever you can take the common. So here like 2m2, we can take the common from these two. So finally, this will be the equation. Now, here, up to this, it's a fine. So this will be the general one. Now, here, these two terms we are getting. Here, we according to the given load, we have to just replace this one. Now, another condition is what? When E is constant. So, that time simply 1 by E will be there. So, that E got multiplied. So, after taking 1 by E common, this will be there. And then it will multiply it here. So, 6E. Now, if I also is constant, means E and I both are constant. Then, what happened? Again, same 1 by I common, so that I will get multiplied here, and that becomes 6 EI. Okay, so now finally for unsettling support, what happened? That H1 and H3 will be equals to 0. So right side totally it becomes 0. So this will be the final equation. Now come to the question. But the question was for uniformly distributed load. So from the table, that value of 6AAL, that is 6A1 A1 bar by L1 is here, because 2 we divided into 2, that's why it's 2. So that is given as W0 LQ by 4, and 6AB by L is given as W0 LQ by 4. Right? Just substitute these two values here. So after substituting in the previous equation, that first equation is here. Right? Next, after substituting, again you can take E and I constant. After taking E and I constant, this will be the equation. And for the settling process, what will be there? This will be there. Why? Because these two will be becomes that H1 and H3 becomes equals to 0. Okay. So thus for this question you can just refer math, engineering mathematics. There you can find the derivation and all. So if you have any doubts, you can comment on the video, or you can contact me regarding your doubts. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.